We're going to go back to our beginning problem of solving systems of linear equations, and we're going to use the knowledge we've gained about nullity, rank, and so on of a matrix in order to help us get the answers. So the first theorem here tells us that if we're trying to solve a system of equations and we want to look at whether or not there's even going to be a solution, well, the thing is, if we look at the matrix A, and then separately we look at the matrix that is you get when you join in the right hand side, called the augmented matrix. All right, so this one's the augmented matrix, and this one is the coefficient matrix. And what this theorem tells us is if these two matrices happen to have the same rank, then you are guaranteed to have a solution to your system of equations. And if those two matrices have different rank, then you're guaranteed to not have a solution. So again, the concept of rank gives us a great way to answer this question about whether the system is consistent. That means whether they even have a solution, just by comparing the rank of these two different matrices. Now, this sounds all fancy and stuff, but if you really think about it, what it comes down to is, you solve your matrix here, and maybe you have a row of all zeros in your coefficient matrix, but then when you add on your B matrix and you did the work with it, maybe you got a number there that was not 0 at the end. And so in this case here, you get an extra pivot, which means you would get a one higher rank in this. And so that's why you'd have a different rank between the coefficient and the augmented, and so there's no solution there. So really this theorem is just saying that as long as you don't have a row of all zeros with a non-zero at the end, you're going to have a solution, which in this new fancy terms is saying that the rank of the two matrices are equal. Okay, next theorem up here, another one useful to understand what's going on with systems of linear equations. It says that if you have a consistent system, which means you have at least one solution, then you're guaranteed that you are going to have a unique solution if and only if the nullity is 0. So the nullity is how many free variables you had. So the thing is, if you have no free variables, then you're guaranteed to have only one solution. On the other hand, if you have any free variables, even one of them, that means there's going to be infinitely many solutions to the problem. So again, a nice useful little fact here that the free variables tells you whether or not you are having one solution or infinitely many. And then we come here to the big thing. This is some would say, the single most important theorem in this whole linear algebra section. It's called the Invertible Matrix Theorem. And what it does is it gives you a list of all things that are mathematically, logically equivalent. Some of these are easy to work with, some of them are not so easy to work with. So you just basically use whatever you can on a given problem when you're trying to answer it. So what this tells you is that, first off, if the matrix is invertible, that's our first condition. And if that's the case, then AX equal to B will have a unique solution for every possible B. So what this tells you is that no matter what the right-hand side is, not only is it going to be a consistent system, but it's a consistent system with only a single solution. Similarly, we're going to look at that if you have AX equal to 0, it's called the homogeneous system, the only solution to it is if X equal to 0. Also can say that the rank is equal to the size of the matrix. We can also say that the nullity is 0, the determinant is non-zero, and then the n row vectors form a basis, and the n column vectors form a basis for Rn. So again, all 8 of these are logically equivalent, which means if you ever have any one of them being true, then all of the rest happen to be true as well for free. Again, they're all logically equivalent here. So essentially, you just use whichever one you can find out the easiest in a given problem, and then the rest of them would be consequences of that. So, for example, if you knew the matrix was invertible, then you're guaranteed to have solutions. If you know the determinant is non-zero, you're guaranteed to have solutions, and so on. And in fact, if you look further into this, there are a lot more than 8 things that are all logically equivalent. I believe when I first took this class, I saw like 10 or something. I've seen 15 or so now since then. These are the 8 that I decided to put into this video because they're some of the useful ones for us. But really, there's a long list of these, and it's just trying to show you that all of the things that we're learning here, from systems of equations, from determinant, from nullity and rank, all these things are all interconnected. And the whole idea of linear algebra is you can have 2 things that sound different, but you can still use it to solve the problem. Regardless, these are the things that we want to look at now that we have all this new terminology.